I'm Nasko Stamenov. I'm from Bulgaria. And today we are going to talk with you about rockets. Why rockets? Well, two main reasons. Well, you see over there somewhere my name, Nasko Stamenov, that are two of my names. I have three. So first is given name. The second one you see, Stamenov, is my surname. But there is an interesting story about my father. So I have father's name also. And my father is born in 1963 in Svoge in Bulgaria. Well, 1963 is quite close to 1961. And in 1961, from around there somewhere 2,000 kilometers from Baikonur, the first human went into space, Yuri Gagarin. So my father is named after him. My father's name is Yuri. I am Nasko Yuriev Stamenov. So this is one reason to do rockets. My father's name is that of Yuri Gagarin, although he's called Yuri Stamenov, of course. The second reason is that we're in Kazakhstan, where Gagarin flew. So it is nice to talk about rockets in the place in the world where half of the rockets are shot from. All right, so to talk about rockets, we need to know a thing or two about rockets. So a rocket is everything that will put some mass behind it and it will propel itself forward. So what we need for that, like a balloon. A balloon potentially can be a rocket, but you'll see a flaw in it. So if I get a balloon and if I just blow it up, now I have a place with quite high pressure, and I have a small way for that pressure to escape from. But if I just let it go, it will go everywhere. It's missing something. Well, it's missing a way to make it directional. So, for example, if I take another balloon and help with the direction, now we'll have something that goes where we want it to go. So here I have a line, all right? And here I have a small tube. And on that small tube, I'm going to stick my balloon. So now, when I let it go, all right. From time to time, it doesn't work as much. But we have now direction. And for rocketry, we really need that direction. Without direction, we're not doing anything. But balloons, of course, are not rockets. They're a bit too clumsy to do our job. So let's try another one. All right, what I have here? Sorry? Bottle. All right, I have here a bottle. And this bottle is way more rigid than any balloon. Well, I still can crush it easily, but it's way more rigid, which means that I will have no trouble to make it directional. So if I fill it with pressure, if I fill it with gas, and this gas escapes only from here, well, there'll be quite a lot less movement in every direction, and I may actually be able to shoot it somewhere over there. So let's just make the pressure way higher with this bicycle pump. Now you see it goes into a straight line. Well, as straight of a line as a random bottle of water can achieve. And there's nothing in the bottle, only air. All right, so let's see it again. And you see, in first, when the bottle has the most pressure, it goes straight. At some point, when it starts to lose velocity, what it does is that it goes askew. So now we have some knowledge about what we're needing? We are needing a vessel that can hold itself properly, and that vessel also needs to have enough stuff from inside so it sustains its flight in the proper length of time. So, of course, just air is not the proper thing. We need real fuel. And the history of rocketry actually is quite substantial. The first rockets used for fun were before about 1,200 years. The first rockets that were used for war date at the same time. So we have used rockets for quite a long time now. And the first rocket fuel out there, I have it in this cup. So the first true rocket fuel is called black powder. And black powder was dreamt somewhere in China, so quite close by. And it has only 3 components. The only 3 components in black powder are sulfur, coal, charcoal, and potassium nitrate. So, sulfur is quite easy to get. To get sulfur, you just go to your favorite volcano and scoop it up. So far, so good. Charcoal, not difficult to attain also. If you want charcoal, you just get some wood, you burn that wood without it burning to ash, just to coal, and here you go, you have charcoal. Now, potassium nitrate is a bit more tricky, because potassium nitrate nowadays is done in multitude of tonnages every day, because we can make ammonia. But 1,000 years ago, they could not make easily ammonia. That's why they gathered something. They gathered piss, either from humans or from pigs. So you have really big bucket of piss, pee, urine, and you mix it with potash, the white ashes that are left when we burn stuff. You mix it and start boiling it. Mix and boil, mix and boil, mix and boil, it becomes a syrup. You sieve that syrup through cloth and you get clear liquid. More potash is added, you boil, you mix, you get syrup. You filter it. You boil, you mix, you get syrup. You filter. You boil, add water, boil, sieve, add water, boil, sieve, until you get really nice yellowish crystals. But you have a problem, because if those crystals have salt, it will not work. So what people did was take that crystal and test for salt. Mind you, those crystals were made from pig's piss, so it's a bit nasty. But if it's not salty, then you're game, then you have that. And this actually gave way to gunpowder, to guns, to rockets also. So let's cut off the lights, no lights please, and see how black powder burns. Lights please. No lights? Yes lights? I don't want any lightning. Hey there, volunteer, lights. Yes. All right. All right. So look closer here. We'll see some sparks and whatnot. Of course, this is my burner. We'll see about it later. All right. Huh. Was that nice? All right, lights please. So this is what black powder burns like. And did you see sparks? Those are small pieces of coal. Well, this black powder I done yesterday. I took this pestle here, which is a thing you can find in your kitchen, and I mixed them a bit. So it's not the perfect black powder. Perfect black powder is done when you take the things and put them in a mill, in a ball mill for hours and hours on end. So this one was good enough. But nowadays, we virtually don't use black powder. Mostly because it's quite smelly. If you are quite close to me, you may feel the smell of egg that's gone bad. Eggy smell. This is from the sulfur. Пожалуйста. So, nowadays we don't really use black powder anymore. For rockets, for fireworks, we use crimson powder. So, I'm telling you that we have used rockets for war and for fun. Well, the first people who used rockets for war were the Koreans. The Koreans had these racks of fireworks that they just shot at the enemy. The first European bombardment with rockets was in, what was it? In 1799. And of course, during the Napoleonic Wars, there was quite a lot of rocketry. Even there was a rocketry regiment in the coalition army, in the English army at the time. All right, nowadays we do not use black powder anymore. Every firework that you have seen ever is propelled by this red thing here. And this red thing here is called crimson powder. Well, it's called crimson because it's red, and powder because it's powder. All right. It's crazy how these things make sense. So, a little bit of crimson powder will go a long way. So, this is our crimson powder now. And what's in there? We still have the same oxidizer, so the same thing that gives oxygen, potassium nitrate, the thing from the pig piss, right? Nowadays it's not from pig piss, all right? But we still have it here. We have rust, iron oxide, the red rust that you get on your family car. If you have a Ford, well, Fords here are not so popular, but people really wonder how to keep Fords from rusting. Well, you have no way of doing that because they make the thing out of rust to begin with. And the last thing is something that you are familiar with, but I don't think you imagine used for that. The last thing is vitamin C. Do you know what vitamin C is? Do we eat it or do we just need a little bit of it? Just a little bit. But this doesn't mean that vitamin C doesn't have calories. Vitamin C is actually a proper fuel. It has a lot of calories. And here we are going to see exactly that. So, tell me now, did the black powder had flame? All right, wasn't it bright? What was that then? Lamps. It had flame. All right, did it have sparks? All right, both flame and sparks we don't want for our firework fuel because otherwise it can ignite the other stuff and it can explode prematurely. So this one should only give out smoke, and this is what we call solid rocket fuel. So we have solid mixture that can burn on its own because it has its own oxygen, and we can use it to propel stuff. So let's check out this thing with the lights on. We don't need to cut off the lights for that. So I have my skewer stick, and I don't need the flame. I need only the ember. does it have quite a lot more smoke? Yes. And did you see any sparks? Do you see quite a lot of flame? Just a little flame where it went. All right, that's substantial amount of smoke. I like it. All right, so that thing is what nowadays fireworks have. All right, but what about other fuels? What about other things that we can rocketry with? Well, nowadays this solid fuel is used for fireworks. Other solid fuels are used for space exploration. Like if you have seen, for example, Ariane, the European rocket, or you've seen the American space shuttle. The American space shuttle has these two pencil-like things on the side. Those are solid rocket fuel boosters, but they do not really have the same stuff. They have aluminum, and they have ammonium perchlorate, which is a strange thing that we do not talk about. And of course, normal glue for tiles in your bathroom. That's what a rocket fuel is. All right, so now here, I'll show you another one. So, the first rocket planes that saw any action saw it in the Second World War. And they were actually normal propeller planes, but they had what we call a rocket booster. And this rocket booster gave a little bit of oomph at some point so the plane can skedaddle if the need be. The plane can go away quickly if the need be. So that rocket fuel I actually have here. It has only two components. And of course a catalyzer, but for catalyzers a bit more later. So we need hydrogen peroxide, and this is the concentrated stuff. This is 37%. This is nasty. Just a little bit of it. And now I'm going to make myself a long spoon out of aluminum foil, because I'm going to break this hydrogen peroxide into its two main components, which are oxygen and water. And of course, we already said, to make a rocket, you need... Are you waving at me? All right. To make a rocket, we need... Well, I see you all, so yeah, hello. All right, cool. To make a rocket, we need a fuel chamber and stuff to go out, some mass to throw away. Well, if we produce a lot of hot gases and a lot of hot liquid and we throw it away, well, that's a rocket. So, what I have here for that little spoon is a little thing called potassium permanganate. Margancovka. And potassium permanganate is interesting to attain in Kazakhstan because for some reason some of your bureaucrats said you can make drugs out of it. Well, you cannot. You may make explosives out of it, but drugs no. So in my book it's quite more suitable to have in the pharmacy than it is currently. So, I'm going to pour the potassium permanganate into the flask. A reaction will occur, the hydrogen peroxide will break apart into oxygen and water vapor. And the temperature will become so high that this water will actually boil off. So, we may see a stream, a rocket stream. So, let's check it out. 3, 2, 1. Oh! All right. So now imagine a pilot piloting its plane with propeller, and other planes are coming, and he's like, no, I don't want that. He flips a switch, this falls there, the plane goes if it does, because 80% of those planes, this thing bursted and poured hot liquid on the pilot. It was a death trap. We don't make this kind of rockets anymore. It should have worked. It didn't work well. And of course, also I have the problem that now inside I have this nasty black liquid. But this is actually one of my favorite parts, because what was the fuel in crimson powder? Do you remember? So in crimson powder we had the potassium nitrate, we have the rust, and what was the third thing? Margansovka's this. Sulfur was in black powder. Come on, vitamin? Huh? Vitamin C, yeah. So vitamin C is a good fuel, and it will react even if we don't really have the property of rocket fuel. So vitamin C is this yellowish powder. This is our potassium permanganate. And look now. Like on the teleshop, right? I really like that part, because I now have reason to talk about your vitamin C and also to clean my glassware. 2 in 1. Perfect. The perfect experiment. All right. Okay, so we do not use that anymore. What we can use is every possible mixture that can blow up. And here I have something like that. So I have a bottle, but this bottle is special because it has a hole. So bottle with a hole. And this is water, and I'm going to pour the water in the bottle with the hole, but not so that it goes out from the hole, all right? So just below the water line. Of course, some more water will be quite splendid. That's tonic water though. I've never done it with tonic water, but let's see. A man's gotta do what man's gotta do, right? So, now, I have rocks. Have you ever seen a rock? Huh? Yes, no? Never, all right. Well, let's see about those rocks. I have question to you. All right. Nasty looking things. All right. That is a rock. All right. And do rocks burn? No. All right, let's test that hypothesis. That rocks don't burn. Well, this one certainly doesn't. But this is a special type of rock. It is called calcium carbide. Calcium carbide. When combined with water, it will produce a gas. This gas is called acetylene. Acetylene. And mixtures of acetylene and oxygen that have no more than 25% acetylene are actually explosive. And if we have explosive gas, then we can propel something with it. Then we have a rocket. So what is going to happen is I'm going to throw a rock in there. I'm going to cover it with a cup. And when the gas starts forming, I'm going to put a little flame on there and see whether or not it really goes. So you see bubbles, and let's see. And you saw how ever so slightly it went off. Let's wait for a bit more. This one is too big to go there. All right, now we're cooking. All right, did it went off? Yes. All right, so this is acetylene. And as you can see, we have explosive mixture. So we have hot gases going out of something. So we have propulsion. Let's try it again, although the second time usually doesn't work as well. Told you, not as well. Ah, wait, well, wait till see the rest. So, acetylene can be used for fuel, and it's a gas, so it's quite easy with it to burn. Nowadays, people are wanting to make something that we call a hybrid rocket. And this one rocket is a bit strange. So, you see here, I have a flask, and I have some strange piece of macaroni. All right, I don't only have a strange piece of macaroni, I have a bamboo stick. And it's not a bamboo stick, it's a bamboo tube. I'm going to cram a macaroni piece in the tube. And I'm going to cram the tube into this hose. All right. So now, what I'm going to do next is I'm going to take that syringe, which is quite sticky of soap. I'm going to fill it with a little bit of hydrogen peroxide. You already saw that hydrogen peroxide can produce a lot of gases, a lot of oxygen. And this is exactly what I need. I also need a compound, a catalyzer to break apart the hydrogen peroxide, and this is manganese oxide, a chemical cousin of our merganzovka. All right. So now I have it there. I'm going to fill that syringe with hydrogen peroxide. This one is a bit weaker, only 15%. All right. I'm going to fill the syringe with it. Okay. We have it in the syringe. I'm going to put that stopper in there, and I'm going to start pouring a little bit of oxygen producing reagents into there. And you see some steam going out. So let's check out what will happen if we were to put that thing near a flame. All right. If we have enough oxygen, if we produce enough oxygen, what is going to happen is that our pasta, yeah, go on, pasta. Our pasta will become a small rocket. All right. We have it now. All right, all right. Almost. All right. You see how it starts to go. Do we have enough of this thing? We start to have quite a lot of oxygen going out. You see steam. We don't really care about steam, do we now? But what we care about is if this pasta can burn on its own. And if done properly, you're going to see a rocket propulsion. Do you see the sparks? Do you see how it lights up? Lights, please. Lights, please. All right. Okay. That now is a rocket. All right. So we have a little bit of propulsion out of there. And we're going to stop it, of course, at some point, because we don't really want to burn ourselves with a pasta, right? And if you hear it, it actually makes a really, really loud sound. All right, lights now. And the whole pasta is burning. All right, lights. All right, lights on. Ah, cool. So, what is good in this type of course, they don't do it out of pasta. Pasta is just the easy thing to make. What they do it of is rockets. Rockets can be their own fuel. And the good thing about those rockets is that we can make them go and make them stop at whatever pace we please. We can actually make them stop mid-flight. But now, I think I'm going to show you two more rockets, which are my favorite. They have the same stuff in there. They're what we call spirit rockets, alcohol rockets. Quite a lot of rockets use alcohol as fuel. So here I have a big nice bottle of ethanol, drinking alcohol. So what I'm going to do is I'm going to pour some into this bottle. First, I want just to clean up my bottle, all right? And now I'm going to pour a little bit more. So, ethanol is also really nice fuel. And I have oxygen from the air. The first rocket that put animals into space was a modified V-2 rocket. And it was fueled by almost the same thing. It was fueled not by ethanol but with methanol, and not by air but pure oxygen. And what we'll have here is a real rocket. You saw that bottle in the start, right? And it didn't go far, did it? This one should be a bit better. So what I'm going to do is I'm going to shake it about. All right, steer it up, and let's see. All right, I'm going to just change the lighter because I don't think this one. All right, let's try it again. So a little bit of ethanol inside, and that's way better, isn't it? All right, here is a good uploading spot. All right, that now is a real rocket. All of those were just model, and model that is, but this is the most precise model that we have. We have a burning chamber, combustion chamber, we have a nozzle, and we really have a mixture of burning gases. Just a spark, those gases ignite and shoot out. But of course, the good thing to do is to have it bigger, isn't it? So I have it a bit bigger. No, this one will not fly. We're going to put it that direction, all right? It will not fly. Does somebody know how big is that bottle? How many liters it is? Sorry? 19. Do you know why? Is there anybody here who knows why this bottle is 90 liters? Because 90.1 liters is exactly 5 gallons. This is imperial measured bottle. This is USA standard bottle, 5 gallons. This is why it's such a strange number. So, do we have the same things as in here? Do we have combustion chamber? Do we have combustion chamber where the things can combine and burn? All right, do we have a nozzle? All right, so it's a rocket. We just need the fuel. And there is a bit more. So what we are going to do is I'm going to fill it with ethanol. I'm going to shake so we have the ethanol vapors. I'm going to burn it. You'll see eventually. And then I'm going to put it that way. I'm going to stop it with my hand after it burns. It will be filled with hot gases. So this bottle is actually quite strong. I can step on it without any problem. And it's made out of polycarbonate. It's hard. But when I stop it, the hot gases are going to start to cool down. And gas that cools down shrinks, or at least attains lower pressure. And what is going to happen, you say? The bottle will shrink. Only with one hand, I should be able to shrink the bottle. So let's see it then. All right, so a hefty 2 shots of vodka. All right, so a little bit of spirit in there to get the party going. Now I need to shake it. Shake it, shake it, shake it, shake it, so I have a lot of vapors. All right, seems about right. And now we are going to put that skewer on fire, and we are going to turn out the lights. Lights, please. All right. And посмотрите. No? All right, once more. Let's see what's the problem here. Maybe a lack of oxygen, maybe a lack of ethanol. We're going to see about that. So I'm going to pour. So first I'm going to pour some air in it. Then some more ethanol in it. Then I'm going to shake more. All right, and let's try it again. So we light the stick on fire. All right, turn on the lights, please. And you see the bottle and how it shrinks. With only one hand, I can squish that bottle. And of course, if I let go, the air will pour in and you'll hear a sound. All right. So, that, my dears, was my little demonstration about rocketry. So, now you know how to do some rockets. Thank you for your attention.